Hello students. So today we are going to discuss one more problem from solid state physics, and this question came in IIT-JAM 2013 examination, and is a question number 9 from the subsection of crystallography. So basically the question is we have to find, question is basically talking about the BCC structure, body centered cubic structure, and we have to find the fraction of volume which is unoccupied in the BCC lattice. Okay, see, there is a lattice. Lattice has their own volume, and we know that in the lattice there is atoms. Okay, from the different lattice there are some different type of atoms in a one unit cell. So what we have to find? We have to find the fraction of volume which is unoccupied. Which is unoccupied. That means which is free. Okay, so for this, let's solve the question. There's a 4 option is given. Okay, I have made a diagram for the BCC lattice. This is a BCC lattice, 8 atoms at the corner and 1 atom at the body center. Okay, so for this, let's suppose the side of this BCC lattice is A. So since it's a BCC, that is body centered cubic, that means the volume of the unit cell will be A cube, that is volume of the cube, that is A cube. So volume of unit cell. Volume of unit cell will be A cube. Okay, but we have to find the volume which is unoccupied. Okay, let's suppose I'm giving you an example that will lead to understand means properly. Let's suppose there is some box. Okay, and let's suppose the volume of the box is some y. Okay, and there's a 2 spherical balls. This is a 2 spherical ball present here, and there has means let's suppose volume is x and its volume is z. Okay, so in a similar way we have to find the volume which is unoccupied, that is with this volume. This will not be y, this will not be x plus z. Okay, so in the similar way I have to approach this question. Okay, so see, the volume of the unit cell is A cube. Now we will find the volume of the unit cell in which atom is present. Okay, so we know that the effective number of atom which is present in a unit cell for the BCC lattice is 2. Okay, so we are writing the volume which is occupied, volume occupied by the atom in unit cell. Okay, if we have to find volume unoccupied, for that I'm finding first the volume which is occupied by the atom in the unit cell. So let's suppose there is a n number of atom in the unit cell, and if we multiply this n with the volume of one atom, that is 4 by 3 pi r cube, then we will get the volume occupied by the atom in the unit cell. Okay, so what is n here? What is r here? That's the main question. So we know that the relationship between r and a for the BCC lattice is under root 3 by 4 of a. Okay, fine. And what is n here? N is the effective number of atom present in the unit cell of the BCC lattice. And I'm not going in the deep, but I will write the formula and derive what is n here. Okay, so I'm drawing here. There's a simple formula to finding the effective number of atom in any cubic lattice, that is n is equals to 1 by 8 times the number of atom present at the corner plus 1 by 2 times the number of atom present at the face plus number of atom present at the body center. I am denoting here by the BC. Okay. So if we see the BCC structure, how many number of atoms present at the corner? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so number of atom is 8. So 1 by 8 into 8. How many atom at the face? 0. There is no atom at the face. It will be 0. And how many atoms at the body center? It is 1. Okay, so it will be 1. So what will the value of n here? The value of n will be 2. The value of n will be 2. So we have find the value of n is 2 and r is root 3 by 4a. So now we will find the volume occupied. So volume occupied, and this will be n multiplied by 4 by 3 pi r cube. Okay. So it will be n is 2 here, 2, 4 by 3 pi, and value of r is root 3 by 4a. This will be root 3a by 4 of whole cube. Okay, let's simplify this further. It will be how much? 8 pi by 3, and if we'll open this cube, it will be how much? It will be 3 root 3 a cube by 64, and this will be root 3 pi by 8 a cube. Okay, so this is the volume which is occupied. This is the volume which is occupied by the atom in the unit cell. But what we have to find? We have to find the fraction of volume which is unoccupied. See, the total volume is a cube. This much volume is occupied by the atom in the unit cell. So what will be the volume which is unoccupied? A cube minus this volume. That means total volume minus occupied volume. That will be our unoccupied volume. So the volume which will be unoccupied, that will be a cube minus root 3 pi by 8 a cube. A cube will be common, and it will be 8 minus root 3 pi by 8 a cube. This will be the total unoccupied volume. And in the question, we have to find the fraction of volume. That means if we just divide it by the total volume, that is a cube, we will get the fraction of volume. Okay, so this is the total fraction of volume which is unoccupied, that is 8 minus root 3 pi by 8, and the correct option is A. Okay, see, this is a thorough procedure, a whole complete procedure. If you guys know about the atomic packing fraction of BCC lattice, okay, then you can do this within a 30-second or 40-second, I guess, because the total packing fraction of BCC lattice is how much? You guys know, if it is a 0.68. This is a total packing fraction of the BCC lattice. If this is the total packing fraction, so what will be the volume which is free, that is, this is unoccupied? 1 minus 0.68, that will be 0.32. Okay, so if you simplified all these 4 options completely, okay, if you simplified this one, you will get 0.32. If you simplified this one, you will get 0.68. Similarly, if you simplified this one, you get I guess around 0.26, and if you simplified this one, you will get 1.2 something. So that means it's very simple that this option is correct. But I have told you the complete procedure to find out the unoccupied volume. Okay, thank you.